Dear student, in previous class I discussed about the difference between electrolytic cell and galvanic cell, electrode potential, oxidation potential, reduction potential, standard electrode potential, standard hydrogen electrode, some problem related to the electrode potential, and finally I discussed about the electrochemical series and importance of electrochemical series. Now I will discuss about the battery. Battery is the arrangement of electrochemical cells which is used as an energy source. It is compact and portable. Battery should have reasonably for long time whether used or not used. Next point is the drop in voltage when used should be steady, not suddenly. Drop in voltage should be steady, not suddenly. Next I discuss about the commercial cell. There are three types of commercial cell. One is your primary cell, second is your secondary cell, third is your fuel cell. First is your primary cell, second is your secondary cell, third is your fuel cell. Primary cell are the galvanic cell which cannot be recharged. There are many examples of primary cell. The examples of primary cell are dry cell, mercury cell, etc. Now I will discuss about the dry cell. In dry cell, a zinc container is present and the zinc container acts as anode. Here a cardboard is coated over the zinc container. Then a graphite rod is taken like this, and the graphite rod is surrounded by MnO2 and carbon. This is your MnO2 plus carbon. In this region, NH4Cl plus ZnCl2 is taken. A paste of NH4Cl and ZnCl2 is taken here. This is your graphite rod which acts as a cathode. This is your pitch seal. Here a metal cap is placed. This is your positive end. This is your negative end. This is the diagrammatical representation of dry cell. In this cell, these are the reaction takes place at anode. The zinc undergoes oxidation, gives Zn2 plus 2 electron. At cathode, 2 NH4 plus 2 MnO2 plus 2 electron gives MnOOH, 2 molecule of MnOOH plus 2 NH3. The name of this compound is manganite. Now I can write the net cell reaction. Zn plus 2NH4 plus 2MnO2 gives 2MnOH plus Zn2 plus 2NH3. Now this NH3, which is liberated as the byproduct, react with the Zn2 plus form a complex compound, that is your Zn NH3 4 2 plus, your 4 molecule NH3 is taken. The cell potential of dry cell is 1.25 volt to 1.5 volt. In this case, the Zn converted into Zn2 plus, and here Mn4 plus changes to Mn plus 3. This is all about the dry cell. Next I will explain about the Nonstick equation. Nonstick equation gives the quantitative relation of electrode potential with the concentration and temperature. So I can write the quantitative relation of electrode potential with the concentration and temperature is called Nonstick equation. Suppose I will take a general reduction reaction which occur at the cathode. For a general reduction electrode reaction, suppose I will take a general reduction electrode reaction. Suppose N plus N electron gives a M. This is your aqueous, this is your solid. According to Nonstick equation, I can write a relation E electrode reduction equal to E0 electrode reduction minus RT by MF ln concentration of the product, that is your M solid, divided by concentration of the reactant, that is your N plus aqueous. Now I can convert the ln into log. We know that ln x is equal to 2.303 log x. So I can write E electrode reduction equal to E0 electrode reduction minus 2.303 RT divided by NF into log of concentration of M solid divided by concentration of Mn plus aqueous. Here T equal to temperature, that is 298 Kelvin. R is equal to gas constant, the value is equal to 8.314 joule into Kelvin inverse mole inverse. F is the Faraday's, whose value is equal to 96,500 coulomb. N is the number of electron, and this term, that is your M solid concentration, that is called molar concentration of M solid, and this term is called molar concentration of Mn plus, that is your molar concentration of Mn plus aqueous. Suppose this is your equation 1. Now put the value of T, R and F in this equation. Then I can write a equation, that is your E electrode reduction equal to E0 electrode reduction minus 0.0591 divided by N into log of concentration of M solid divided by concentration of Mn plus aqueous. This value will be found by putting the value of T, R and F in this equation. We know that the concentration of pure solid and liquid is unit. So here I can write concentration of M solid equal to unit. Now put the value of concentration of M solid in this equation. Then I can write E electrode reduction equal to E0 electrode reduction minus 0.0591 divided by n into log of 1 by concentration of Mn plus aqueous. Similarly, I can write the Nonst equation for a new electrode reaction. Suppose I will take a new reaction, that is M1 solid gives a M1 N plus N electron. This is an oxidation reaction. Suppose I can write for a general oxidation electrode reaction. This is a general oxidation electrode reaction. For this reaction, I can write the Nonst equation E electrode oxidation equal to E0 electrode oxidation minus 0.0591 divided by n log of concentration of M1 N plus aqueous divided by concentration of M1 solid. Here the concentration of M1 solid is 1 because we know that the concentration of pure solid and liquid is unique. So I can write E electrode oxidation equal to E0 electrode oxidation minus 0.591 divided by n into log of concentration of M1 N plus aqueous. This Nonst equation is written for the reaction Mn plus aqueous plus n electron gives a M solid. This is your general oxidation electrode reaction. This is your general reduction electrode reaction. Now combine these two reactions, then I can write the cell reaction. The cell reaction is your M1 solid plus Mn plus aqueous gives a M1 N plus M solid. For this reaction, I can write the Nonst equation. The Nonst equation is your E cell equal to E0 cell minus 0.0591 divided by n log of concentration of M1 N plus divided by concentration of Mn plus. Here I can write aqueous. Here also I can write aqueous. Finally, I can write a general Nonst equation, that is E cell equal to E0 cell minus 0.0591 divided by n into log of concentration of product divided by concentration of the reactant. Now I will explain the Nonst equation by taking some example. Suppose I will take the example number 1, Daniel cell. In Daniel cell, the cell reaction is your Zn solid plus Cu2 plus aqueous gives a Zn2 plus aqueous plus Cu solid. At anode oxidation reaction takes place. So I can write Zn solid gives a Zn2 plus aqueous plus 2 electron. For this reaction, I can write the Nonst equation like this: E electrode oxidation equal to E0 electrode oxidation minus 0.0591 divided by n into log of Zn2 plus concentration divided by Zn solid concentration. Here the n value is 2, so I can write here 2. We know that the concentration of Zn solid is unique, so I can write E electrode oxidation equal to E0 electrode oxidation minus 0.0591 divided by 2 into log of Zn2 plus concentration. Now I can write the reaction at cathode. The reaction is Cu2 plus aqueous plus 2 electron gives Cu solid. For this reaction I can write the Nonstick equation, that is E electrode reduction is equal to E0 electrode reduction minus 0.0591 divided by 2 into log of concentration of Cu solid divided by concentration of Cu2 plus aqueous. We know that the concentration of Cu solid is unit, so I can write E electrode reduction equal to E0 electrode reduction minus 0.0591 divided by 2 log of 1 by concentration of Cu2 plus aqueous. For this cell reaction, I can write a Nonstick equation, that is E cell equal to E0 cell minus 0.0591 divided by 2 into log of concentration of Zn2 plus aqueous divided by concentration of Cu2 plus aqueous. We know that E cell equal to E0 cell minus 0.0591 divided by 2 into log of concentration of the product divided by concentration of the reactant. Here the product is Zn2 plus and Cu solid. Since the concentration of Cu solid is 1, so here only concentration of Zn2 plus aqueous is written. Like that, if you think about the reactant, there are two reactants, one is your Zn solid, another is your Cu2 plus. Since the concentration of Zn solid is unit, so here only concentration of Cu2 plus aqueous is written. Suppose I will take the example number 2. Suppose I will write a cell reaction. Cell reaction is Cu2 plus 2Ag solid gives Cu solid plus 2Ag plus aqueous. Then what will be the Nonstick equation for this cell? From this reaction it is clear that at anode I can write 2Ag solid gives 2Ag plus aqueous plus 2 electron. For this reaction the Nonstick equation is E electrode oxidation equal to E0 electrode oxidation minus 0.0591 divided by 2 into log of concentration of Hg plus power 2. Look at that, here 2 mole of Hg plus is written, so it is bound to write concentration of Hg plus power 2. Suppose here 3 mole is written, then I can write Hg plus concentration power 3. Here 2 is written because here 2 electron transferred from 2 molecule of Hg to 1 Cu2 plus ion. Similarly, I can write at cathode Cu2 plus 2 electron gives Cu. For this reaction I can write the Nonstick equation E electrode reduction equal to E0 electrode reduction minus 0.0591 divided by 2 into log of 1 by concentration of Cu2 plus aqueous. Look at that, here 2 electron removed from 2 Ag molecule and that 2 electron gained by 1 Cu2 plus ion. That's why here 2 is written, also here 2 is written because the value of n is 2. For this equation I can write the Nonstick equation like that: E cell equal to E0 cell minus 0.0591 divided by 2 into log of concentration of Ag plus power 2 divided by concentration of Cu2 plus. This is the Nonstick equation for this cell reaction. Next I will discuss about the example number 3. Suppose I will take a cell reaction like that. 2Al plus 3Ni 2 plus gives a 2Al 3 plus 3Ni. This is your cell reaction. Then what will be the non-stipulation for this cell reaction? Add a node 2Al gives a 2Al 3 plus 6 electron. Now I can write the non-stipulation for this reaction. E electrode oxidation equal to E0 electrode oxidation minus 0.0591 divided by 6 into log of concentration of Al3 plus power 2. Here 6 electron is transferred from 2 aluminum molecule to 3 nickel ion. Similarly, add cathode 3Ni2 plus 6 electron gives 3Ni solid. So I can write the non-stipulation for this reaction. E electrode reduction equal to E0 electrode reduction minus 0.0591 divided by 6 into log of 1 by concentration of Ni2 plus power 3. Now I can write a non-stipulation for this cell reaction. E cell equal to E0 cell minus 0.0591 divided by 6 into log of concentration of Al3 plus power 2 divided by concentration of Ni2 plus power 3. This relation can be obtained by combining these two relations. Now I will explain about the application of non-stipulation. First application is your calculate EMF of a cell. Suppose the cell reaction of a cell is like this: M solid plus M1 N plus aqueous gives M N plus aqueous plus M1 solid. This is your cell reaction. Then the non-stipulation is your E cell equal to E0 cell minus 0.0591 divided by N into log of concentration of Mn plus aqueous divided by concentration of M1 N plus aqueous. By putting the value of concentration of Mn plus aqueous and concentration of M1 N plus aqueous and also the value of N and also the value of E0 cell, I can able to find out the value of E cell. The second application is your, by the help of non-stipulation we can calculate the equilibrium constant. For the calculation of equilibrium constant, we can use an equation which is derived from the non-stipulation, that is your E cell equal to 0.0591 divided by N into log of K. Now put the value of N and E cell, then I can able to find out the value of K, that is your equilibrium constant. Next application is your calculation of pH. For the calculation of pH, we can derive a formula from non-stipulation, that is your pH is equal to E cell by 0.0591. These are the application of non-stipulation. Now I will solve some problem related to the non-stipulation. This is your cell representation. Here some data is given: E0 Zn2 plus Zn is minus 0.76 volt and E0 Cu2 plus U is 0.34 volt. Then calculate the EM of the cell. By the help of this cell representation, I can write the cell reaction like this: Zn plus Cu2 plus gives Zn2 plus Cu solid. This is your cell reaction. For this cell reaction, I can write the Nonstick equation like that: E cell equal to E0 cell minus 0.0591 divided by N into log of concentration of Zn2 plus divided by concentration of Cu2 plus. Here the concentration of Zn2 plus is your 0.1 m and the concentration of Cu2 plus is your 0.01 m. The value of N is your 2 because your 2 electron is transformed from zinc to Cu2 plus ion. Now I am to find out the E0 cell. For E0 cell, here these two data is given. We know that E0 cell equal to E0 cathode reduction minus E0 anode reduction. There are three formula for the calculation of E0 cell, but it is bound to apply this formula because here the electrode potential reduction potential. That means the two data given in reduction potential. Now put the value of these two data in this equation. This value is larger than this value, so this value is taken for E0 cathode reduction and this value is taken for E0 anode reduction. So I can write E0 cell equal to 0.34 minus 0.76. That means I can write E0 cell equal to 1.1 volt. Now put the value of E0 cell here. So I can write E cell equal to 1.1 volt minus the value of N is 2. So I can write 0.0591 divided by 2 into log of, here the concentration of Zn2 plus is 0.1. So I can write here 0.1 divided by, here the concentration of Cu2 plus ion is 0.01 m. So I can write here 0.01. Now I can solve this. I can write E cell equal to 1.1 volt minus 0.0591 divided by 2 into log of 10. The value of log 10 is 1. So I can write E cell equal to 1.1 volt minus 0.0591 divided by 2 into 1. After solving, I can write E cell equal to 1.07 volt. Now I am to find out the EMF of the cell. So we can write EMF of the cell equal to 1.07 volt. Now I will solve the problem number 2. Calculate the EMF of the following cell at 298 Kelvin. The cell having the cell representation this is the cell representation. Here some data is given: E0 Sn2 plus Sn is 0.14 volt and E0 Ag plus Ag is 0.8 volt. Now I am to find out the EMF of the cell. From this cell representation, I can write the cell reaction. The cell reaction is your Sn plus 2Ag plus gives Sn2 plus 2Ag. This is your cell reaction. Now apply the Nonstick equation for this cell reaction. I can write E cell equal to E0 cell minus 0.0591 divided by N into log of concentration of Sn2 plus divided by concentration of Ag plus power 2. Here 2 is written. Here the value of N is 2. Here the concentration of Sn2 plus is 0.1 and the concentration of Ag plus is 0.01. Our aim to find out the E0 cell. For E0 cell, I can write E0 cell equal to E0 cathode reduction minus E0 anode reduction. Here two value is given. Among the two values, this value is larger than this value. So put this value for this term and put this value for this term. So I can write E0 cell equal to 0.8 volt minus 0.14 volt. After solving, I can write E0 cell equal to 0.66 volt. Now put the value of E0 cell here. Then I can write E cell equal to 0.66 volt minus 0.0591 divided by n means n is your 2. So I can write here 2 into log of concentration of SN2 plus is your 0.1. So I can write here 0.1 divided by concentration of Ag plus is your 0.01. So I can write here 0.01 square. Now I can solve E cell equal to 0.66 volt minus 0.0591 divided by 2 into log of 10 to the power cube. Now I can write E cell equal to 0.66 volt minus 0.0591 divided by 2 into 3 log 10. The value of log 10 is 1, so I can write E cell equal to 0.66 volt minus 0.0591 divided by 2 into 3. After solving, we can write E cell equal to 0.57 volt. Our aim to find out the EMF of the cell, so we can write EMF of the cell equal to 0.57 volt. Now I will solve the problem number 3. Find the pH of the following acid solution. This is the cell representation of a cell. The measured EMF of the cell is 0.178 volt. Here E cell equal to 0.178 volt. For the calculation of pH, we know a formula. pH is equal to 0.0591 divided by E cell. Here the value of E cell is 0.178. Now put the value here. So I can write pH is equal to 0.0591 divided by 0.178. After solving, the value of pH is your 3.012. So we can write the value of pH equal to 3.012. Next I will solve the problem number 4. Calculate the equilibrium constant for a reaction. Ni solid plus U2 plus aqueous gives you solid plus Ni2 plus aqueous. Given the value of E0 Ni2 plus Ni and E0 Cu2 plus Cu as minus 0.25 volt and plus 0.34 volt respectively. Our question is find out the equilibrium constant. We know that E cell equal to 0.0591 divided by n into log k. Our aim to find out the E cell and n. For calculation of E cell, remember two formulas are given. If the concentration is given, then it is bound to apply the Nonstick equation. If the concentration is not given in the problem, simply you can apply E cell equal to E cathode reduction. Here standard reduction potential is given, so I can write E0 cell equal to E0 cathode reduction minus E0 anode reduction. Among these two values, this value is larger than this value, so put the value for this term and put this value for this term. So I can write E0 cell equal to 0.34 volt minus of minus 0.25 volt. After solving, I can write E0 cell is equal to 0.59 volt. Now put the value of E0 cell, that is 0.59 volt here. So I can write 0.59 equal to 0.0591 divided by here n is equal to 2 because 2 electron transfer. That means here I can write 2 into log k. Imply that I can write log k equal to 2 into 0.59 divided by 0.0591. Imply that log k equal to 20. Imply that k is equal to 1 into 10 to the power 20. Our question is find out the equilibrium constant. So we can write equilibrium constant equal to 1 into 10 to the power 20. Now I will solve the problem number 5. Calculate the equilibrium constant for the following reaction. The reaction is your Fe solid plus Cd2 plus aqueous gives Fe2 plus aqueous plus Cd solid. Here given data is your E0 Cd2 plus Cd equal to minus 0.40 volt, E0 Fe2 plus Fe equal to minus 0.44 volt. Our aim to find out the equilibrium constant. We know that E0 cell equal to 0.0591 divided by n into log of k. Here the value of n is 2. Our aim to find out the E0 cell. E0 cell equal to E0 cathode reduction minus E0 anode reduction. These two values is your reduction potential. So it is bound to apply this formula. Now put these two values in this equation. This is your larger than this. So this is used for this and this value is used for this term. So I can write E0 cell equal to minus 0.4 volt minus of minus 0.44 volt. After solving I can write E0 cell equal to 0.04 volt. Now put the value of E0 cell here and put the value of n here. Here the value of n is 2 because the 2 electron transferred from iron to Cd2 plus. So I can write 0.04 volt equal to 0.0591 divided by 2 into log k. After solving I can write log k equal to 1.3536. Imply that k is your anti log of 1.3536. After solving I can write k is equal to 22.57. Our question is find out the equilibrium constant. So I can write equilibrium constant equal to 22.57. This is all about the Nonstipulation, application of Nonstipulation and some problem related to the Nonstipulation. Next I will explain about the relation between free energy and EMF of the cell. Remember an important point in electrochemical cell, the chemical energy is converted into electrical energy. This electrical energy is produced by electrical work, and the electrical work is equal to the decrease in the free energy. The negative value of the free energy indicate that the work is done in the system on the surrounding. So we can think that the electrical work equal to total electricity flowing into EMF of the cell. Suppose n mole of electron is flowing, then the total charge is your NF. So I can write electrical work equal to NF into E cell. For a spontaneous reaction, del G value is your negative. At temperature 298 and concentration 1m, I can write del G is equal to minus NF E cell. For standard condition, I can write del G0 equal to NF E0 cell. This is the relation between free energy and EMF of the cell. Remember an important point, total charge equal to Q equal to N into F. F means Faraday. 1 Faraday equal to 96,500 Coulomb. Now I will solve a problem related to the relation between free energy and EMF of the cell. This is your problem. For the cell reaction, this is your cell representation. Calculate the maximum work that can be obtained by operating the cell. Here E0 Mg2 plus Mg equal to minus 2.37 volt and E0 Ag plus Hg equal to 0.8 volt. Our aim to find out the maximum work. Maximum work means you can think about the electrical work. We know that electrical work is equal to the decreasing in the energy. We know that del G0 equal to minus NF E0 cell. Here the N value is 2 and the F value is 96,500 Coulomb. The value of E0 cell is not given. For calculation of this value, these two data is given. We know that E0 cell equal to E0 cathode reduction minus E0 anode reduction. Among these two value, this value is larger than this value. So this value is taken for this term and this value is taken for this term. So I can write 0.8 minus of minus 2.37. After solving, I can write E0 cell equal to 3.17 volt. Now put the value of E0 cell here. So I can write here 3.17 volt. So I can write del G0 equal to minus 61181 C into V. That means Coulomb into volt. 1 C into V equal to 1 joule. So I can write here minus 61181 joule. 1 kilojoule equal to 10 to the 3 joule. So I can write minus 61.181 kilojoule. Our aim to calculate the maximum work. So I can write the answer maximum work equal to 61.18 kilojoule. Don't write the minus sign. The minus sign or plus sign is only used to indicate the work is done by the system or on the system. That means here minus sign is written, so the work is done by the system. Remember an important point: if W is equal to negative, then the work is done by the system. If W is equal to positive, then the work is done on the system. This is the problem related to the relation between free energy and EMF of the cell. This is all about the electrochemistry.